Hi there and welcome to physics. Today we're going to be reviewing the concepts we've been talking about and learning about with impulse and momentum. So here are some few things we've covered this week in this activity. So first of all, if we're talking about what type of relationship exists between momentum and velocity, what we've said all along is that they have a direct relationship. And so it's important to remember that they have a direct relationship between those two elements, momentum and velocity. Right? So what you do to one impacts the other. In terms of the relationship between momentum and mass, they also have a direct relationship. What you do to one, it directly impacts the other. So if I increase the mass, that's going to increase the momentum. If I increase back over here the velocity, that's going to increase the momentum as well. So that has a very direct relationship there. Some examples of this, if I said, okay, the relationship between, since it's direct between velocity and momentum is direct, if you double the velocity of an object, what will happen to its momentum? So let's say, for example, that we had a velocity and we know that momentum is the equation is P times M times V. So let's pretend we had an object that maybe had a mass of 1 kilogram, and it had a velocity of 3 meters per second, right? So the momentum for this would be 3, in this case here, 3 kg times meters per second. So that becomes our momentum there. If we double the velocity, so 3 times 2 is a 6, and we go 1 times 6, then in terms of our momentum, it also becomes 6, so we can see it's doubled there. So if we're doubling this times 2, in terms of our output over here, it's also being doubled as well. So if we double the velocity, then we're also going to double the momentum. That's part of that direct relationship. Similar idea, if we talk about the mass of an object being direct relation between momentum, and then we ask what happens if we triple the mass. Okay, so again, we have momentum is equal to mass times the velocity. And so if we said, well, the mass was, in this case, let's say the mass is 2 and the velocity is 3. Well, our initial momentum would be 6 kilograms times meters per second. And if we were to triple the mass, this is going to be from here times 3, then I'd be looking at 2 times 3 is 6, and then I would multiply 6 times 3 and have 18 kilograms times meters per second. And so once again, in terms of momentum, it also is multiplied by 3. So if I triple the mass, then my momentum is also going to be tripled as well, because it is a direct relationship. Let's look at a couple practice problems. So if an object has a mass of 4 kilograms and a velocity of 3.5 meters per second, what is the magnitude of momentum of the object? So we start, first of all, with our equation that the magnitude of momentum is found by doing P for the momentum is equal to the mass times the object's velocity. And in this case, we have a clear mass of 4 kilograms, and our velocity is 3.5 meters per second. And so we multiply 4 times 3.5, we end up with simply our momentum is equal to 14 kilograms times meters per second. So it's just a matter of just remembering that that is our equation for the momentum. If we ask then, okay, let's look at a couple different things, which one has the greater momentum, then we're going to be asked essentially to do a couple problems and see which one has the larger result, the greater momentum. We know already that our equation is that momentum equals the mass times the velocity. So if I have a mass of 30 and a velocity of 2.5, the momentum is equal to 30 times 2.5. And in this case here, 30 times 2.5 is equal to 75 kilograms per meters per second, or times meters per second. Here, momentum equals 25 times 3. And 25 times 3 is 75 kilograms times meters per second. So in this case, neither one has a greater momentum. They actually have the same momentum because they end up with both having a 75. So even though the masses are different and the velocities are different, what we get as a result of them being multiplied together ends up being the same. And so the momentum is going to be the same for both of these situations here. A student and her bike have a combined mass of 80 kilograms. What is the speed of the student and her bike if they have a momentum of 230 kilograms times meters per second? I'm not sure why there's a little box right there. Little just change over, I guess. Interesting. So in this case, for the student riding the bicycle, we are looking at the speed of the person. So once we're going to probably be looking for really the velocity. So we know that our momentum equals the mass times the velocity. So if we want to get velocity by itself, we're going to divide both sides by the mass so that velocity equals the momentum divided by the mass. And so in this case here, we have a mass of 80 kilograms, and we have momentum of 230 kilograms times meters per second. So 230 kilograms times meters per second. And so 230 divided by 80, in our case here, is 2.875. The kilograms cancel out, and you're left with meters per second for our velocity in this case. So what should you leave it as? If you leave it at that, that's okay. Again, our test tomorrow, quiz tomorrow is on paper. So if you leave it like that, that's going to be fine. If you were to round that up to 2.9, I'd be okay with that as well. Again, showing your work is the most important part for me. A 115 kilogram student is riding his electric scooter at 27 meters per second, and in order to avoid hitting a squirrel, comes to a sudden stop in 1.8 seconds. What is the magnitude of the change in momentum of the student? This is important here because now we're talking about the change in momentum. We've said before that momentum equals mass times velocity, which is true, but we can also talk about the change in momentum. And when we talk about change in momentum, you're doing not just mass times velocity, but mass times the final velocity minus the initial velocity. And that's important to differentiate from our other equations here. So in this case, we do have a 115 kilogram student, so that's okay. We can keep the 115 there for the mass. But then I have to consider the other elements here. We have riding the scooter, we have a speed here for velocity of 27 meters per second. That's great. We also have a time going on there. Now you can notice here there's no place for time in this equation. And that's okay. Sometimes there are elements or parts of the problem that are given to us that we don't need in order to solve what it's asking for, change momentum. So my final velocity in this case, because we're going to come to a stop, is going to be 0. My initial velocity is 27 meters per second. So I end up with 115 times a negative 27, or in this case, a negative 3,105 for my change in momentum. So it's kind of dropping down there. So we can see it's definitely, it's negative because it's coming to a stop, but because momentum we're talking about here is a force, I can't have a negative force. So I really need to take the absolute value of that and say that it's going to be 3,105 kilograms times meters per second in this case for the change in momentum of the student. So yeah, your answer began with a negative, but we don't have a negative force. We're going to make it positive there. All right, so this one's interesting because we have a little extra information here with the time, but we don't need the time in order to figure this one out at this point. We could do other things with it, but we don't need to worry about that. All right, so next we have that object has a mass of 7 kilograms and is traveling at a velocity of 4.7 meters per second. If the mass of the object is tripled, what is the new momentum? All right, so we're going to triple the mass. So our momentum is mass times velocity. And so our initial mass is 7 and times a 4.7, but we're going to triple this. So instead of 7, we're going to say 7 times 3, which is 21. So we'll do 21 times 4.7, and our new momentum then becomes 98.7 kilograms times meters per second is our new momentum if we're tripling things, which actually is going to be this valued. If we multiply that out, that would be triple it, would still be 98.7 because, again, of that direct relationship, right? This right here is actually equal to 32.9. And if you did 32.9 times 3, what do you end up with? You end up with 98.7 because it's times 3, just like this is times 3. All right. Next, we have a ball, a 0.035, I should have written down there, sorry, kilogram ball, is traveling at 30 meters per second to the right when it is hit by a paddle. The ball then reverses direction and travels at 24 meters per second. The ball is in contact with the paddle for 0.0062 seconds. What's the magnitude of force exerted on the ball? So we're looking for force. Now I have a couple things. I have a mass of 0.035 kilograms. I definitely have a velocity, but I have an initial velocity, which is going through the right. So we'll call that a positive 30 meters per second. And then we have a second velocity, the final velocity, which is going to go the other way, negative 24 meters per second. And I'm doing negative because it's changing direction. So I'm going to use positive to go to the right and negative to go to the left. In terms of time, I do have a time here of 0.0062, and I don't have a force value in this situation here. So I'm trying to figure out what the force is going to be. Now recall that we know that the force times the change in time is equal to the mass times the change in velocity. So that's going to be, those are two equations that equal one another. Okay, so I know in this case here, I'm looking for my F value. So I'm going to divide both sides by T to make up a new equation. So my force is going to be equal to the mass times the change of velocity, which is the final minus the initial, all divided by T. And so that becomes the equation I'm working with here in order to solve for the magnitude of force. So my mass is going to be 0.035. My FV, or my VF, my final, is negative 24, and I'm going to subtract from it 30. That's my initial, and that's all divided by my time, which is 0.062. So when we work this out, we then end up with 0.035 times 24 plus 50 is a negative 54, all divided by 0.0062. And we multiply this together and divide by that number there. Then we end up with 304.83. And again, we could say it's either kilograms times meters per second. You could also write it as newtons times second. That all works as well. But we end up basically with 304.83 newtons per second. And that becomes the magnitude of force. So what's critical about this problem is that you do have a time that you're going to use, but we also have a change in velocity because it's going to the right and then it's going to the left. So keep that in mind. A 40-kilogram baseball is in contact with a bat for 0.0083 seconds and exerts a force of 15,800 newtons. What impulse is delivered to the ball? So our impulse equation was J equals the force times the change in time. All right, that was our part there. So what do you notice? Well, we notice that there is no mass in this equation, is there? So there's no mass to worry about. We can kind of ignore that. We don't have to worry about the mass in this situation. So we're going to look at the force, 15,800, and we're going to multiply it by the time, 0.0083. And we're going to find out, in this case here, that our impulse is 131.14 newtons times seconds. And that is our impulse value there. So a little extra information that we didn't need because of just the way the equation is set up. And one final one for the day. We have a 0.03 kilogram ball, hits the ground with a speed of negative 26 meters per second. The ball is in contact with the ground for 0.038 seconds, and the ground exerts a 60 plus newtons force on the ball. What is the magnitude of the velocity after the ball hits the ground? After the ball hits the ground. So again, we have a mass of 0.03. We have a initial velocity of negative 26. We want the velocity after it hits the ground, so that's our final velocity, which we don't know. And let's see what else we know. We have a time element of 0.038, and we have a force value of 60. So with this information here, we want to do a couple steps. First, let's determine our impulse value, our J. Our J equals force times the change in time. So we're going to do 60 times the time, 0.038, and that gives us a J value equal to 2.28. Now that I know what the j equals, I also know that force times time is also equal to mass times the change in velocity, or that same j is equal to this. So j is now there, so 2.28 is equal to the mass of the object, 0.03, times the change in velocity. The velocity is the velocity final, which I don't know, minus the velocity initial, which is a negative 26. So the first thing I'll do is divide both sides by 0.03. So 2.28 divided by 0.03 is equal to, look at my notes real quick here, sorry. So 2.28 divided by 0.03 is equal to 76. So 76 equals velocity final plus 26. And that's a plus because minus and minus is a plus. So now I'm going to subtract 26 from both sides and end up with 50 is my final velocity, or 50 meters per second is my final velocity in this situation. So a couple steps for this equation, this process here, finding out first your impulse value, your j, and then using that to set it equal to your magnitude there, so mass times the change in velocity. All right, that's really it for today. Hope that gives you a quick little recap review, and you have some good notes that you bring with you tomorrow for your quiz. Good luck, and we'll see you tomorrow.